Okay, hello everyone. Please allow me to reintroduce myself. My name is Zora Zerin Zviano. You can call me Zora or Z for short. I am a student from the class 03 from both numerical method and fluid mechanics classes, and I am here to give out my opinion and my submission for this week's assignment. And since in the previous class we've talked about circular economy, which can be roughly defined as the approach of recycling a certain material or energy that would usually go to waste, but in this case is used to produce um, like a certain product or to fuel a certain activity where all of these like excess energy and materials would usually go to waste or be just distributed um like as garbage or as trash. And for the circular economy sake, I'm going to use skyscrapers as an example. So let's dig into it. Now, before I get into the numerical method and the fluid mechanics aspect of this topic of this discussion, I would like to lay out the status quo or the current circumstances that we're currently facing in modern society in terms of skyscrapers. So, what is up with skyscrapers? Um, the number one example that I put here is equality in infrastructure. There is the demand for vertical living or the demand to establish tall buildings is at an all-time high because we're approaching the this like general idea of a modern society. And in terms of Indonesia itself, you can definitely see that the um the presence of all of these like modern and sophisticated buildings only exist in Jakarta or in Java Island in general. And so there is a demand for equality or equal distribution of these types of infrastructures all over Indonesia in every single island of the country. And I've also stated before, the demand does not only lie in equality, but it also lies in what humans or people would utilize those said buildings. One of them being vertical living. Since the human population is at an all-time high as well, like it's something that is mushrooming and it's something that is ubiquitous and it happens all in all corners of the world. And so since there's more people and there's less land, so we turn to vertical living or a housing alternative that requires less land but utilizes the most space by actually building your way up instead of building your way um like by the width or like the surface area of the earth. And lastly is sustainable development. As you can probably tell, you don't really have to be an engineer. You don't have to be pursuing a career in engineering or STEM in general to notice that there is a high demand for moral awareness in terms of infrastructures and architecture in general, because the process of constructing these types of buildings would undoubtedly lead to a lot of carbon emissions and a lot of one of the examples that I could think of is soot or like dust debris that would get scattered in the air, which also affects air quality, and that is definitely not good for the environment. So since there is a demand for these types of infrastructures, but um, we have to recognize that sometimes it's just unavoidable. But just because it's unavoidable to actually produce CO2. That doesn't mean that we can decrease its production. And for the circular economy aspect of it, from what I've saw in my research, one of the most unique innovations that I found was recycled earth mass. So let me ask you a question. How or more specifically, what is the first step into building a skyscraper? Like, what is the first thing that you would do? Some people would assume that the first thing that you do is to build these buildings from the ground up. This is actually a common mistake because that's actually, well, I'll say it as like the second step of it. The first step that you would do is not build it from the bottom up. It's actually to set a sturdy foundation to these buildings by digging your way down to um, the earth and to set, let's say, metal stakes or pillars or columns to act as like a support for these buildings to actually be able to get up in the air. So with all of these dirt and soil that's been dug up from earth and replaced with, well, let's say, metals, what would you do with all of those excess? So some people actually decided to use all of those leftover dirt and convert them into walls as substitute for your conventional brick walls. So this is definitely something that is uncommon, let's say, at least not in Indonesia. And as you can probably tell with all of the pictures that I've provided below, that I know some of you guys may be thinking, like, making a wall out of dirt is definitely not something that is, it doesn't sound pretty or it doesn't sound aesthetically pleasing, but from the pictures that I have put into the slide, you can definitely tell that that is not the case. Since there is also a very specific criteria that the soil have to um, fulfill, like soil moisture and its sturdiness in order for them to actually hold its shape and being, like dried and then erected into like house like walls. You can see that you can actually integrate not only like the sense of functionality but also aesthetic, since you can see that you can mix and match between colors and textures as well. So it's definitely something to look into and is definitely something to invest, not only because it's environmentally more sustainable, but it does also serves an aesthetic purpose as well. Now, moving forward to the numerical method and the fluid mechanics aspect of this discussion. So, what is CFD, or computer fluid dynamics for? So, I have brought forth 3 points. The first one being to test design efficiency, and this is because um, it is definitely a lot easier for you to test your designs through a certain medium. That medium is being said, refers to the CFD software, which has a lot of benefits that leads to the second and the third point, which is to reduce physical prototyping. You don't really have to have like a physical manifestation of your designs in order for you to test them. You can simply just log into your computer and test the designs themselves. So you don't have to have any like expenses to make certain like dioramas or little blocks for you to test out your building's structural integrity in general. And which leads us to the third point, which is minimizing cost and failures. So since you don't really have any um, physical manifestations, you don't really have to uh, allocate money to test out your designs through physical designs or physical prototypes. And by failure, it also means that it prevents you from actually building like your set of designs in real life with real life calculations and designs and construction, and actually being faced with engineering failures, such as your supports are not good enough, or that your materials are not the proper ones that you should use for your designs. And next up is the correlation between the application of CFD in skyscraper development. I'm going to bring forth 2 points here. The first one being integrating functionality and aesthetic, which is something that I have also mentioned in the previous slide about recycling earth mass. So, an example here, as provided by the three pictures below, is the 432 Park Avenue building. So I think you can probably see, I don't know if it's clear, on the left hand side, the rendering, like the building's design rendering, has some parts of it where it's labeled with like the color red. And the red here represents the lights that you can see on the picture on the right. And the purpose of these red levels of the building is actually the parts of the building where it's just an empty floor. So it's just levits, like there's nothing in it. Like there's just structures like columns on the sides of the building, but the inside is empty. Now, what do these empty floors, what is their purpose? Like what does it do? So um what it does is that, like one of the most common issue that skyscrapers face or endure is wind gushes, or the strong and heavy winds that could potentially topple these buildings over. Now, one of the precautions that the engineers and architects made before, when they do actually construct these buildings, is not only do they have to dig into the earth and create solid foundations to it, but they also have to anticipate and prevent these wind gushes from actually toppling over the building and the residents of that said building. So, what the Park Avenue building is doing through these empty floors is to enable all of those wind gushes to just flow through the building, so um, it wouldn't experience as severe of a wind gush as other buildings would, if the ones that do not actually have these empty floors. So not only does it serve a purpose, but it also looks aesthetically pleasing as well. And the second and the last point would be, and still in correlation with the wind gushes, is to prevent incidents and miscalculations, because this is something that is very common for architects to stumble upon when they are constructing tall buildings, is wind gushes. Or one of the most common example would be the if I'm not mistaken, the name is the Venturi effect, which is where, as you can probably tell, like as you can see here, I don't know if you can see. Okay, there's my cursor. There, the blue indicates the spots that is near a building, which experiences the least amount of wind gushes or strong winds. And the red is the complete opposite. This is like the spot where you would experience the most um, wind gushing. And the reason why the red is present in between buildings is because of the said Venturi effect, which is due to um, the sharp angles of certain buildings, as you can see with like all of the right angled ones here on the right hand side of the cursor, the one that I'm pointing to, is it highly affects like the flow of the wind that is going through these two buildings. And since this spot right here, the deep red spot um is present between these two buildings, this is the number one spot that is going to experience the most wind gushes. So why does it matter? Like, what does this, like, how does it impact the surrounding environment? So, it's definitely something to look out for, because it's definitely going to affect the pedestrians that are going around these buildings. Like, they are going to experience severe discomfort when they have to travel or commute through this path right here. So I think that would be all for my presentation. In short, the CFD, in terms of its application in real life, can be seen through the construction of skyscrapers. And some of the things that you have to look out for would include um, preventing incidents with wind gushes, as well as creating strong foundations. But just because um, there is a high demand for all of these buildings that are notorious for their detrimental environmental effects, that doesn't mean that we cannot decrease them. So one of the innovations to do that you can actually go for would be the recycling earth mass. Thank you.